Alaikum. How are you, students? I start with the holy name of Allah, the most merciful, beneficial, and the supreme power of the universe. Today we will start unit number 4, turning effect of forces. Page number 85. Lecture number 23. Today, first I will explain turning effect of force. First we will explain torque. The rotational effect produced in a body is called torque. Rotational effect produced in a body or the turning effect produced in a body is called torque. So before going into detail of torque, we have to explain some points. So first we will explain parallel forces. Parallel forces. Parallel forces. The forces whose lines of action are parallel to each other and all all of them have them act in the same direction are called parallel forces. So here we have to explain. I will explain two things: line of action, line of action. Line of action is the line along which the force is acting. The line is the line along which the force is acting, along which the force is applied. And point of action, the point at which the force is acting. Point of action. If this is a point and you apply force F1 at this point, if you apply force F1 at this point, this is called point of action of F1, and this line along which the force is acting is called line of action. Line of action. If two forces acting at this point, this point is called point of action, and this is called line of action of F2. If F3 is acting at point C, this point C is called point of action. This point C is called point of action, and this is called line of action of point C. Line of action of force F3. As these lines are parallel and having different point of action, so called is called parallel forces. So when the point of action is different and line of action are parallel is called like parallel forces. So parallel forces. Parallel forces. First, point of action must be different. Point of action must be different. And second point, and line having parallel line of action, having parallel or anti-parallel. Line of action. So those forces which have different point of action and having parallel line of action are called parallel forces. Parallel forces is divided into two types. One, like parallel forces, and second one, unlike parallel forces. Unlike parallel forces. This is an example of like parallel forces. For like parallel forces whose line of action are parallel to each other and all of them act in the same direction. Two lines, these are four lines. So minimum you can take two lines. So lines are parallel and acting in the same direction, so it's called like parallel forces. Introduction. Now I have already give you the introduction, so just read this one. A little consideration will show that such forces do not meet at any point because they are parallel, though they do have same effect on the body on which they act. The forces whose lines of action are parallel to each other are known as parallel forces. Classification. Like the forces whose line of action are parallel to each other and all of them act in the same direction is called like parallel forces. This is an example of like parallel forces. This is unlike parallel forces. Lines are parallel. Point of action are different. Point of action are different. And direction are anti-parallel. Direction are different, acting in different direction. So are called unlike parallel forces. So in unlike parallel forces, point of action is different. Point of action is different. Line of action are parallel. Direction is opposite. Direction is opposite. These are these are the explanation of parallel forces, like parallel forces, unlike parallel forces. These two forces are called unlike parallel forces. These are called parallel forces, like parallel forces. Two parallel forces will not intersect at a point. The line of action of forces are parallel, so that for finding the resultant of two parallel forces the parallelogram cannot be drawn. Here collectively they are called unlike parallel forces. Only these two are called unlike if you compare these two, and if you compare these two, these are called like. But as a whole, if you take all the forces, then it is called unlike because the direction are different. So before going into the next topic, first I will explain that like parallel forces, we explained parallel forces which which in which line of action are different, which satisfy two conditions: point of action having different point of action, and second line of action are parallel. Line of action are parallel and point of action is different. If point of action is different, line of action are parallel, then it is called parallel forces. The third is direction. If direction is same, is called like parallel forces. If direction is opposite, then it is called unlike parallel forces. Now we will explain addition of vectors. Forces are vectors. This means that they have both size and direction. When adding forces, we must add them like lines, taking length and angle into account. Adding forces is the same as length and as combining them. When several forces are combined into a single force, this force is called the resultant of these forces. For example, this is vector A and you have vector B also. If you join the tail of first vector to the head of the second vector, then this is called the resultant vector, which have the same effect as the combined effect of B vector and A vector. This is called addition of vector. And in this, if you draw a vector here, this is called tail and this is called head. So here we take the tail of first vector and here we take the head of the second vector. So when we join the tail of first vector to the head of the second vector, it is called head to tail rule. Head to tail rule. It is called head to tail rule. So we have added vector by head to tail rule. The addition of vector is different from the process you add 2 plus 3 is equal to 5, 2 minus 3 is equal to minus 1. So it is scalar addition. So vector addition and subtraction are different. They have different criteria and different procedure. Now we add graphically by head to tail rule. We take the support of head to tail rule. In this we follow some steps. First, draw an arrow to represent the first vector using a ruler and protractor. You will first you will draw vertical, horizontal and vertical lines. Draw the lines. First step, you will draw the lines, and in second step, label these lines. You draw the lines in first steps. If label these lines accordingly. If north, east, west, south is given, you will draw according to north, east, west and south. And if x and y axis is given, then you will draw according to x and y axis. X axis and y axis. This is negative y axis, this is negative x axis. And if east, west, north and south is given, east, west, north and south, then you will label accordingly. Now in third step, we will make a suitable scale for it. Third step is missing, but I will write make a suitable scale. Make a suitable scale for it. For example, you cannot draw a line of 2 kilometer or 5 kilometer. It is a length of 5 kilometer. You cannot draw. So you will draw a line. You will select the scale. 2 kilometer is equal to 1 centimeter. So 5 kilometer will be equal to 2.5 centimeter. So a 2.5 centimeter line will represent a distance of 5 kilometers. So you will make a scale like this for it. So then in fourth step, draw the line according to selected scale at the given angle. Draw the line according to selected scale. To the selected scale at the given angle. Apo, he said that 3 meter along x-axis and 2 meter along y-axis. Then join the tail of first vector to the head of the second vector. Okay, I will do it on blank page. The first step is draw horizontal and vertical lines. This is the first step. Label these lines x-axis and y-axis. Now make a suitable scale for it. So I will draw a line of 10 kilometer at 30 degree along x-axis. So you will draw a line of you will draw a line with the scale we choose is 2 kilometer is equal to 1 centimeter. So 10 kilometer will be equal to 5 centimeter. So we will draw a line of 5 centimeter which represents a length of 10 kilometer, and the angle we will draw this line at an angle of 30 degree. So first you draw horizontal and vertical lines, then you label these lines, then you choose a scale for it, because you cannot draw a line of 2 kilometer on a page, or a line of 10 kilometer on a simple page. So you make a suitable scale for it. Then we draw the line according to the at the given angle, uh, at the given angle according to selected scale, according to the selected scale. Now next coming topic is resolution of forces, but we will do it tomorrow. Now I will make a little bit revision. First we will explain parallel forces. Parallel forces. Parallel forces are the forces, this is the first topic, whose line of action are different, point of action are different, but line of action are parallel. Then we have studied different types of parallel forces, like and unlike, whose line of action are parallel, whose line of point of action are different, but line of action are parallel, and who are called like parallel forces. And unlike parallel forces, whose line of action are parallel, point of action are different, and direction are also opposite, so called unlike parallel forces. Then we done the addition of vectors. We add vector by head to tail rule. Head to tail rule. Head to tail rule. In head to tail rule we follow 4 steps. First step we draw, in first step we have wrote that in first step draw horizontal and vertical lines. Draw horizontal and vertical lines. Second step, label these lines accordingly. In third step, make a suitable scale for it. Make a suitable scale for it. Fourth step, draw the lines according to selected scale. Fourth step, draw the lines. Now I will explain some more points. Before going into resolution of vectors, I will explain. First, I will explain resultant vector. A vector which have the same effect which have the same effect as the combined effect of vectors, as the combined effect of combined effect of combined effect of all the vectors, of all the vectors. Vector which have the same effect as the combined effect of all the vector is called resultant vector. Null vector. A vector which have null vector is a vector which have magnitude equal to 0. Which have magnitude equal to 0 is called a null vector. So null vector is a vector which have magnitude equal to 0 is called a null vector. Now, vector can be graphically represented by writing symbol and arrow over it. For example, if you want to represent a vector symbolically, you have two methodology to represent vector. One, symbolically. By writing in bold face italics. If you write f, it does not mean that f is a scalar quantity, but if you write with more ink over it, like this one, this is bold face italics. Bold face italics. So it is a vector quantity. Or by writing f and putting arrow over it, so it represents a vector quantity, and this also represents a vector quantity. This not represents a vector quantity. So if you write v, it means speed, but if you write v in bold face, it means velocity, means it is a vector quantity. It is a vector quantity. Or you put arrow over it, then it does not represent speed, it represents velocity, which means that vector quantity. So symbolically, vector can be represented by writing in the symbol in bold face italics, or by putting an arrow over it. Thank you, students. Wish you best of luck. In next lecture, we will revise this chapter, the topic which we done today, and the next coming topic will be resolution of forces. Allah Hafiz.